All right, let's dive in. Today we're talking about one of the most powerful forces changing modern industry, and that's deep learning. We're going to look at how this advanced type of AI is basically giving factories a brand new digital brain, transforming them from places that just react to problems to places that can actually predict them. So let's get into how this incredible shift is really happening.
Just think about this for a second. What if your production line could warn you that a critical part was going to fail weeks before it actually broke down? Or what if it could spot a defect so small you couldn't even see it on a product zipping by at high speed? Now, this isn't some far-off science fiction fantasy. This is exactly what deep learning promises to do for manufacturing.
Okay, so what is deep learning really? I mean, we hear the term thrown around all the time, but what does it actually mean when you're standing on the factory floor? Let's break it down into simple terms.
At its core, deep learning is all about teaching a machine to learn from experience, pretty much the same way people do. It uses something called an artificial neural network, which has tons of layers stacked deep. That's where the name comes from. And its job is to just sift through mountains of factory data, things like sensor vibrations or images from a camera, and find these tiny complex patterns that would be totally invisible to a person.
So that brings up the next big question, right? How does this digital brain actually get so smart? How does it go from just looking at raw data to making these incredibly accurate predictions?
Well, it all comes down to the artificial neural network, or ANN for short. And as you can probably guess, the whole system is inspired by our own brains. It's built with layers of these digital neurons that pass information from one to the next, with each layer getting a little bit smarter and looking for more complex details than the last. And here's how that learning process actually works. First, you feed it some data. Let's say an image of a new part. That image passes through all these hidden layers, which analyze everything from basic edges to really complex shapes. Then the network makes a guess, an output, like, yep, this part is defective. Now, if it's wrong, the system uses a really cool process called backpropagation. You can just think of it as a feedback loop. The network gets told, nope, that was wrong, and it actually adjusts its own internal connections to learn from that mistake. It does this over and over and over until its guesses are almost always right.
Okay, so that's enough of the theory. Let's talk about how this technology actually shows up as real tools that people are using on the factory floor right now.
For our purposes, you can really boil this down to two key tools. First, think of convolutional neural networks, or CNNs, as the factory's new pair of superhuman eyes. They're perfect for any visual job. And then you have autoencoders, which are kind of like the factory's ears, always listening to the hums and vibrations of the machinery, trying to catch any signs of trouble.
So let's start with the eyes. CNNs are completely changing the game for quality control. Instead of having to rely on human inspectors, who, let's be honest, can get tired or might miss a tiny flaw, factories can now use this AI to automate the entire visual inspection process with just unbelievable precision.
And just how precise are we talking? Well, the source material we're looking at points to studies where these models are hitting over 99% accuracy in spotting defects. Just let that sink in for a second. That level of reliability is an absolute game changer for improving quality and cutting down on waste.
All right, now let's talk about the ears of the factory, the autoencoders. Their whole job is to prevent those huge catastrophic failures and all the costly downtime that comes with them by hearing problems before they actually happen. This is really the heart and soul of predictive maintenance.
So how on earth do they do that? Well, an autoencoder's first job is to learn the unique sound of a perfectly healthy machine. It listens to all the sensor data coming in and tries to recreate that perfect sound. When it can't, when the sound is just a tiny bit off, it spits out what's called a large reconstruction error, and that error, that's your alarm bell. That's the signal that there's a potential problem, long before that machine ever breaks down.
But, it's not all smooth sailing. Adopting a technology this revolutionary isn't a simple plug-and-play situation. There are some very real challenges that come with implementing deep learning on the factory floor.
For one, you need a ton of high-quality data, and collecting and labeling all of that can be super expensive. For another, training these models takes some serious computing horsepower. But maybe the biggest hurdle of all is something called the black box problem. Basically, the AI can give you the right answer, but it can't always tell you why it came to that conclusion.
And that leads us to maybe the most important question for any engineer or operator out there. If an AI tells you to shut down a machine for maintenance, but nobody can explain the reasoning behind it, how can you really, truly trust that decision?
This is exactly where explainable AI, or XAI, comes into the picture. It's this whole new frontier in AI research that's all about cracking open that black box. The goal here is to build systems that don't just give you an answer, but can actually explain their logic in a way that we can all understand and, most importantly, trust. It turns the AI from some mysterious tool into a transparent partner.
So, when you pull it all together, what's the big takeaway here? It's that deep learning is causing a fundamental shift in how we even think about manufacturing. We're moving away from the old model of just fixing things after they break, and we're entering a new era of what you could call predictive resilience, where factories can see challenges coming and adapt before they even turn into problems.
And that really just leaves us with one final thought. This transformation, it's not coming, it's already happening. The tech is here. So the question for everyone isn't if AI is going to redefine the factory of the future, but rather, are you ready to be the one to lead that change? Thanks so much for joining me.